week 17, lesson 3. Okay, so this video is all about limits approaching infinity. Okay, meaning we are letting x be a very, very, very large number, and then trying to figure out what does the function do at that point. In many of these situations, it's just easiest if you know what the graph looks like. And in other situations, it's just kind of good if you understand what happens to a function. So like, for example, on number 1, if we let x be really, really, really big, okay, millions, billions, trillions, the bigger that denominator gets, the smaller that whole fraction equals, right? If you have 1/2, right, versus 1 over 1,000, we're getting closer and closer and closer to 0. If you know what this picture looks like, it looks like this and it looks like this. So as we're going further this way, this line, right, is getting closer and closer and closer and closer and closer and closer to 0. It's never going to actually get there, right? It's never going to actually equal 0. It's never going to actually cross the x-axis, but that's what a limit means. It's what is it approaching. All right, so like on this one, as we keep letting really, really, really big numbers go into this function, it's just going to equal that really, really, really big number, but negative. All right, on the picture, if you know what this looks like, it's a line with a negative slope of 1. As we keep going towards the right, along this line, it just keeps going further and further and further down to negative infinity. Okay, next, this graph, okay, and maybe you don't know, but hopefully you remember, if the degree of the top is equal to the degree of the bottom, there will be a horizontal asymptote. And it's going to be the coefficient of the top, leading coefficient of the top over the leading coefficient of the bottom. Okay? If you know that there's a horizontal asymptote, then you know that that is also going to be the limit. It's going to be 2/3. That is the limit of that particular function. Okay, so using that exact same logic, let's take a look at this one. The degree of the top is a 1 and the degree of the bottom is a 2. And if you remember about horizontal asymptotes, that means that it has a horizontal asymptote at y equals 0. And that ends up being the limit for this problem. All right, and then this last one, notice that this time we're approaching negative infinity. And I know what this picture looks like, right? When y equals x, I have this line. But this time I'm approaching negative infinity, right? I'm going this way, and this is on its way down. So its limit is negative infinity.